Hello, everyone, and welcome to the next session at the Tech Excellence Conference 2024 with Jimmy Bogard. Jimmy is the creator and maintainer of the popular OSS libraries AutoMapper and Mediator and is well known for promoting vertical slice architecture. He is an independent software consultant based in Austin, Texas, and has received the Microsoft MVP Award every year since 2009. And in this session, he's going to show you how to leverage safe refactoring techniques to move your existing Anemic code base towards a rich domain model. Feel free to write any questions and comments in the chat so we can discuss them after Jimmy's session. But now I hand over the mic to Jimmy. The stage is yours.
All right, thank you, everyone. So yeah, like they said, my name is Jimmy Bogard, and my day job is as a consultant. And I'd say most of the kinds of projects that I work on are not these kind of lovely greenfield, just start from scratch sort of projects, but instead are often dealing with existing kind of, I wouldn't say necessarily legacy systems, but definitely like not the systems you'd want to, be proud of necessarily. And so one of the things I found when I was first being introduced into domain-driven design, it seemed like a lot of the discussions around domain-driven design were really geared around new applications, greenfield applications, and not how do I take existing systems and existing applications and move them towards domain-driven design. And because I mainly deal with existing systems, for me, it's more valuable to understand how do I move a system towards this kind of concept, this idea, rather than if I just start from complete scratch, how do I take a system that is nothing in it and build DDD on top of that. So first, let's just kind of level set about what domain-driven design is. Domain-driven design is just an architectural design strategy in which we selectively distill, organize, and abstract the body of knowledge from the users and the business into the software. So the kind of three things are is we distill, we kind of take things that are very complicated and like pick and choose exactly what we want to get out of them. We organize them, and then finally we abstract them. So we're not trying to represent everything from the real world in our software. And one of the key kind of concepts or ideas from domain-driven design is this idea of a domain model. It is an object model that helps to represent that domain. So the domain model is something that actually predates the big blue book that is behind me somewhere. The thing you keep on your desk to impress your coworkers. It is this idea of a domain model. It's not something that originated from that domain-driven design book, but is actually much more before then. The first time I was introduced to this idea of a domain model was Martin Fowler's Patterns of Enterprise Application Architecture book, which described this kind of idea. And it described a domain model as an object model, so it is object-oriented, of the domain that incorporates both behavior and data. And that's kind of the key thing here, is that it's not just the data. If I have just data, then it's a data model or something that just matches the database. And it's not just behavior. If it's just behavior, then I just have a functional model. So the domain model is intended to be both of those things, both data and behavior. And we're intended to take this concept beyond just kind of nouns and verbs of the system, but truly represents the model that we're trying to represent from the business ideas. Well, like I said at the beginning, I don't usually deal with greenfield applications. I mainly deal with existing systems. And in those existing systems, usually the code isn't what you want it to be. So if you have existing code bases and you want to move it towards this idea of a domain model, then there are techniques we can use in order to do so. And one you've actually probably heard about today in some other sessions is TDD, which includes red, green refactors. So we write a failing test, we write a passing test, and then the step that everyone skips, which is then to refactor. Or if I'm dealing with legacy code, then like there are no tests, so it's more just like, well, gotta cross your fingers and hope, and then safely refactor there at the end. So if I have existing code that I want to move towards this idea of a domain model, there are refactoring techniques we can use to help achieve that end. And luckily, we don't have to invent these techniques for ourselves. We can leverage existing literature, books, videos, things like that in order to do so. And when I was first getting started doing domain-driven design, this is the exact problem that I was encountering, is that I had a pretty large existing system that I was wanting to move towards this idea, but it had, hundreds of thousands of lines of existing code that I had to deal with. I think it was 100,000. I don't know, I never actually counted, but it was more than I expected. So in order to take the existing code and move it towards this domain model, we want to leverage refactoring techniques that help us safely make that transition. And there are lots of books out there in order to kind of give us different techniques and different strategies in order to do so. And so I tend to think of it as like we're standing on the shoulders of giants, that there are lots of folks out there that wrote down different techniques that cataloged these different kinds of operations to make it safe for us to take existing code bases and move them towards these different kinds of models. And the 3 books that really influenced my career when I was first getting started, and even still today, started out with Michael Feather's Working Effectively with Legacy Code book. And in that one, he really talks about how do I take a code base that has no tests and then introduce testing schemes so that it is possible for us to test that code. And once we have those automated tests in place, now we're able to safely refactor the system in whatever way we want. And then the other 2 books on either side, Martin Fowler's Refactoring book, and then my favorite design patterns book over on the right, Refactoring to Patterns. Those are the ones I use on a daily basis to take existing code that has some sort of code smells that I can detect, and then using those techniques, shape the code how I want it to be, or if it doesn't look like I want it to be, then undo those refactorings as well. So I have, for the rest of this talk, we'll be looking at an existing code base that actually matched some code that I was working with early on in my career as well. And in the current state of this application, or this example I've got, it's dealing with a domain of a kind of reward, retail reward system. So these kinds of systems are, you sign up to join some loyalty reward program at some retail store, and in exchange for your personal data and your shopping history, then you get rewards, coupons, 10% off, things like that. So going through this process, this is an existing system I was inheriting. It looked like the original developers were attempting to follow domain-driven design concepts. And I could kind of tell this because, at least when I was looking at the model that existed, the names of everything matched the terms that the business was actually using. So this is the current state of the model as it is today. We have a member class, and this member class represents someone that has decided to join this loyalty program. And it has a certain set of attributes on it, like it has your email, it has your name, it also has like the number of active offers that you have on your membership. And then we have the offers assigned to that individual member, and that's the type there on the right. And then finally, in the lower right, we have some metadata information about those offers to say that there's different kinds of offers with different kinds of behavior. And of course, I simplify this a lot because in real life, it's going to be much more complicated, but that's okay. And this kind of metadata information describes a set of attributes that help affect the behavior of expirations and assignments, things like that. And finally, between the different kind of squares we see in this diagram are these arrows describing the relationships between these different objects. So a member has a collection of assigned offers, and then on the reverse side, an offer has an individual member assigned. And then finally, offer has a specific type. Now, if I were to take this picture and show it to subject matter experts or domain experts or business owners, they could read this and say, yes, this matches the model that we had in mind of modeling the information in our system. Yet we want to have members, and members have a set of assigned offers. And they could look at the names of each of these things, and they would also agree that these names match the concepts that they envision as well. So it's not like we called something member, but they called it something else entirely. It's not like we called something offer, but they called it coupon. The names of all these things match the names that they use on a daily basis as well. The other thing that matches are the names of the associations. So we don't have some just generic collection property name that's like a member has offers. No, a member has a collection of assigned offers. That name assigned represents the nature of the relationship between those entities. So again, I could show this picture to the business, and they would agree that with this picture to say, yeah, this is how we envision our information. This matches our understanding as well. But there's something missing here. This shows all of the data associated with these different entities, but you'll notice here that there's no methods or functions on any of these objects, besides like the sort of normal like equals, that sort of thing. But there's nothing that represents any kind of behavior inside these individual entities. But the behavior does exist somewhere in the application. And depending on your application, like how you've decided to organize things or not, then that's where the true behavior of your system lies. So this could be in, the click handler of the button they click on the page. It could be in some generic service classes or helpers or managers, those generic names that don't really mean anything, but just become sort of a junk drawer of dumping in functionality behavior over time. So the behavior definitely exists somewhere in the system, right? This is not Microsoft Access or something where the user is directly entering data straight into the database. There's some behavior associated with the system, but it's just not represented in those entities. So those exist somewhere. In this case, I've got a services folder where all those different kinds of, all that different kind of behavior lies. And so what I'd like to do now is using refactoring techniques, take the behavior from those services and start to use code smells to determine what kind of refactorings are available, and then using refactoring techniques, push that behavior down into our objects, into our entities. All right, so let me switch over to, this is JetBrains Writer. Now, I have been using JetBrains products forever, and this talk is not an advertisement for JetBrains products. I don't get any money from this, although I should probably get some sort of kickback or something. But I've been using these tools for so long, I literally can't not use them and code on a daily basis. So that's why you'll see a lot of JetBrains stuff here, is just because I can't code without it. But one of the things that's was really impressed with on me early on in my career was to use sharp tools, that is, tools that are very good at what they do, and to learn the different capabilities of those tools so that I could use those tools to their kind of greatest potential during, just kind of like my daily work. So yes, what do we have here? We've got one of these service classes, and this is one of the classes that houses the sort of main behavior of our system. And so this one is called the assign offer service. And judging by the name, it looks like it's responsible for assigning an offer to, I guess, a member here. This, one of the first things I do when I look at a class or type I want to refactor is first just look at the imports up at the top to see what kind of things does this class need in order to function. And the using statements are a good indication of what this class needs in order to do its work. So at the top, I can see system, which is just, that kind of comes with everything. But the first interesting one I see are system net HTTP and system text JSON. And so those two things, HTTP and JSON, indicate to me that this class probably has to call it to some other web API or web service to be able to do its work. So right away, we can see this class will require some, not just external dependency to this class, but some external dependency of our system in order to do its work. Then we're doing async, await, so those two things always come along. And then finally, we see we're using some things from our code base as well. We're using the model, which is going to be the data model, which is not quite yet a domain model. And we're using services, which are, in this case, is going to be an ORM class specific to the ORM we're using, which is, in this case, Entity Framework. Okay, so that's kind of the first thing to do, is just look at the using statements. Now, these are short, right? The 7 using statements, that's not terrible. I've definitely seen classes where the imports are at least an entire screen, and I have to scroll down to get to the end of them. So I won't be going into those kinds of problems. That's just big legacy code problems. But it is a good indication, or at least an indicator of what this class needs to use in order to do its work. The next thing I look at is the constructor. This class is using dependency injection, so it will have in its constructor things that it needs to do its work. And I can see here that my suspicions were correct, that it has this DB context, which is the ORM object in order to be able to talk to the database. And there next to it is the HTTP client. So suspicions are correct. It needs to talk to a database and it needs to talk to an HTTP client. And those are both injected into the constructor here. Finally, I like to see just the individual public methods it has. And I can see that this class only has one public method. And so I'm just going to be focusing on this one. But of course, it may have multiple public methods. But for refactoring purposes, I only focus on one method at a time. I don't try to refactor a bunch at the same time. All right. So in this class, in this method, I look at the signature to see what information it needs to be directly passed in, the direct inputs, and then what does it return to the outside world here. So I see here that it has a request object. So it looks like this is a parameter object that encapsulates all the different pieces of information to be able to do this work. And it returns just task, which is void. It doesn't return anything. Inside this request object are the two pieces of data in order to perform this operation. So I can see in this request DTO, it has a member ID and an offer type. So that kind of tells me here that in order to perform this operation of assigning an offer, I need to know who I'm assigning the offer to, and I need to know what type of offer to assign that individual member. And those two pieces of information are passed in directly through the method parameters here. Okay. Next, I look at the body of the method. And again, if I have to scroll to see the entirety of the method, that's kind of telling me that maybe this method is a little too big. Now, that's not always the case. Like sometimes it is easier to understand a method when everything is sort of together, but I tend to think of code as very malleable and shapeable. And so I often will refactor things and defactor things just to get an understanding of what everything is going on inside of this individual method. Now, I can see though that there are code comments as part of this. So it looks like the previous developer, which by the way was me, also found this method to be too long and left little breadcrumbs, little pieces of information to the next developer to say, this method is too long, and so I'm going to be leaving little bitty comments to describe what each one of these different steps are. So when I see this, it's very difficult for me to understand, just looking at this code, what each of the steps does in isolation, because the local variables could be used anywhere inside of this method from when they're declared anywhere further down. So I can't easily just like from a glance see what is each step actually doing in isolation. So the way we can help figure that out is to extract methods for each one of these different major steps in the method. And then that'll tell us a lot of information about what each of the pieces does. Now, like I said, I'm using JetBrains. You don't have to use this, but I do encourage you to use some automated tool that does refactoring, because these steps, while possible in a manual process, are much easier and much safer to do when you're using tooling to be able to do so. So I use tooling to do so. So in this case, I'm using JetBrains Writer here. So I'm going to extract a method for this first one. And the name of the method, let's see. I usually get from looking around the context and I can see, oh wait, this code comment here was calculate offer value. So let's all the same method, calculate offer value. Okay. Let's do the same thing with the next bit here. I'm going to highlight all of that and then extract a method. And the name being, let's see, calculate expiration date, calculate expiration date. Yep. And finally, the assign offer part. Now here I have to decide, like, how far down do I go? I can see that this looks all sort of object-y stuff, but then down here is the stuff I see basically all the time in any major operation my application does. Is there's some bit at the top that's going to be load up data that I'm going to be working with. So that's this part here. There's like all the business logic-y stuff. And then finally, I need to save the stuff. So that's stuff at the bottom. So I'm not really concerned about the database stuff. Like those are often kind of boring and look almost always the same. So what I'll do here is look at the pieces in the middle here. So let's go ahead and extract a method for this bit in the middle. This method is called, it's like the comment is assign offer. So barring any other ideas, I'll just call the method the same thing, assign offer. Okay. Now, I'd say most of the time in my applications and systems, when I'm presented with this sort of procedural logic like this is the kind of the first thing I do is just, let's break up this long method into a series of smaller methods. And this really doesn't have anything to do with domain-driven design, but it is refactoring. So this kind of refactoring where I'm taking a long method and breaking it up into a series of sort of equally sized or complex smaller method is known as the composed method refactoring. I'm taking one big method and then breaking down into a series of smaller methods where the big method is composed of those individual small methods. Now, the next thing that I will do is then look at each individual method and ask myself, should this method belong here or should it belong somewhere else? And some of the criteria I'm looking at is testability, as well as just the behaviors and concerns associated with that method and any code smells I may encounter. So first up is calculate offer value. Okay, so actually I'm going to fix something here, which is this cancellation token. This is just some stupid .NET thing that always comes along with async. I know the Go people have figured this out, but we haven't quite yet in the C# world. So yes, what I see here is a method that takes a member object and an offer type object and an async thing and returns an int. So its sole purpose in life is to calculate the offer value based on member information and the offer type, and then tell you, okay, here's the value of that offer. And inside of here, I can see that it's using a web service to do so, some API to do so. Now I made this up, like I'm sure there's APIs to do this, but this is just sort of a made up example. But the idea is that there's going to be oftentimes in these kinds of transaction script sort of classes methods that I'm going to have a mixture of different sort of concerns. There's things that are mainly dealing with my domain objects, but interspersed there's probably these other things that really don't have to do with it and are interacting with third-party services or things I just can't control. So in this case, where I have this this calculate offer value method, one of the things I see is that if I want to test this whole class, this is going to pose a problem because I have this thing that I can't control mixed in with everything that I can control. I can't control my database. I can't control all those objects. I can't control whether or not this third-party API is up or down, slow or fast, or even returns what I expect to return. So what we can do is introduce a seam into this, this class to get rid of this dependency on HTTP clients. But we can do this in incremental steps using refactoring techniques. So the next thing I look at in this method is, what does this method need to do in order to perform its job? And I can see that JetBrains writer did not make it static, made it an instance method, which tells me that this class or this method relies on instance fields or dependencies to do its work. And I can see here that it's using this HTTP client. So anything I refactor out is going to need to pull that along as well. So let's do this. So what I'll do is first extract a class that represents this individual method. And I need to give it a name. So we'll call this, let's see, the name of the method is called calculate offer value. So let's call this the offer value calculator. Sure. And it has some little red here that says, hey, you got to fix some of these things in order to make this sort of stuff work. So first of all, I don't actually want to apply the fixed here. And because we have this dependency we'll need to fix in a second here. And the next thing we need to do is this method is private. And so in order to be able to be called, we'll go ahead and make this public. So I'll say make that public, and I'll just place this file alongside there. And let's just see what happens here. Okay, method went away, and at the top, it created this class in order to, it created this offer value calculator passing in the things we see here. Now, one thing it doesn't always get right the tooling is they're never 100%. Like this one, for example, didn't quite understand how to pull over the HTTP client. So this is a thing we're going to have to fix manually. So I don't want to have a reference to the service. I actually just want to pass in HTTP clients like that. And then that's going to be a field here instead of passing in a reference of the parent service. And then that HTTP client is then just going to be used directly here. And then in my service class, instead of passing in myself to the constructor of the value offer value calculator, we're going to pass in the HTTP client, which is the parameter here. And then finally, we can see that this HTTP client field is no longer being used, and we can remove it. Okay, so not quite done here. This is still not testable. I can't mock out or stub out this concrete type. We need to introduce a test scheme for this. So that's what I'm going to do now. I'm going to introduce an interface for that single method. I offer value calculator. We're going to have a method called calculate offer value. And oh, I don't like that name. Let's call this calculate. Seems very redundant. Calculate. Okay. And then the last thing I'm looking at is, okay. So this is still using the type, and it's still not being passed in as a dependency. So let's fix that. I'm going to refactor this to introduce a parameter for the offer value calculator. And it also tells me that there's a parameter that can safely be removed, this HTTP client. So it's no longer being used. It can be just supplied as part of it. Okay. It does give me a warning, say, hey, because we're using dependency injection, there's no public usages of that constructor. So, go fix the DI container to register that dependency. Okay, so let's pretend we did that. Went ahead and fixed our DI container, and still not quite there because it's still not passing in an interface. We can fix that though if I highlight this here, and wait. Oh, there we go. This one of the things about JetBrains is you always have to put the caret in the right place to get the right refactorings to show up. And so what I'm trying to do is I don't want to use the concrete type. I want to use the base type. And so Writer has refactoring for that says use base type where possible. So I will say I want to use the interface, not the concrete type. And so blip, 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 it will change all the references in this class instead of using the concrete type to using the interface if that's possible. One last thing, I hate it when the concrete type is just the name of the interface dropping the I. That doesn't describe the nature of the implementation of this. So we're going to call this the web service offer value calculator, just to be very clear to the next developer that comes down the line. Okay, now I needed to do this because one, I couldn't test this class by itself, right? I had this third-party web API that's going to muck things up in order for me to test this. Now I don't actually have any tests, so I probably should have added some tests here, but that would make this a workshop instead of a conference talk. So just as I'm going here, I would be adding individual integration and unit tests to ensure that everything still works here. Okay, but otherwise there's nothing else I really want to do here. There's an interface thing that is a test scene that allows me to replace the implementation and a unit test, and the real one still gets injected at runtime. But there's nothing else I would really do with this. Like I'm not, it's now down to a single method that's in some interface, so I don't want to do anything else with that. Okay, let's now look at these next couple methods. So the first one I see is this calculate expiration date. So going into this one, okay, so what do we see here? We see a single method that takes a single parameter, okay, but we also see that it's static. And what that tells me is that Writer detected that this set of code does not use any instance fields, which are dependencies. And so this one is more or less a pure method. It has just what it takes in, and based on that it spits out the datetime on the other side, but doesn't talk to anything else in order to do its work. Everything that it needs to work is being passed in through this set of parameters, which is just one. Before we get too far though, I always look for these little squigglies, like little JetBrains helpful things that says, hey, you can make this look nicer. So this tells me that, oh, I can use a switch expression. Okay, that's a new C# feature that, those are the equivalent things in C#, so it's now expression-based switches. It also tells me I can use var, sure. It tells me here I can say, oh, I don't care about that. Then I see that it creates this local variable and it just returns it. That seems kind of silly. Maybe that's good for debugging, but I don't think I really need that. So I'm going to go ahead and inline that variable as well. And then finally, this is now just a single return. And so another feature of C# is I can use expression body members, which just means it's a method that now can be expressed as a single expression instead of whatever we had before. Okay. Now, looking at this, I can see that it's only dealing with the things being passed in, and because it's static, it does not call out into any third-party dependencies. So looking at this, this could indicate that I have an inappropriate intimacy smell, where or feature envy is probably a better name, where I have a method that is doing a lot with some other type or object, but that all that stuff is not located on that individual object. There's a nice refactoring from JetBrains in order to help address this, and it's known as make method non-static. So with this refactoring, in order to make this method non-static means what? Make it instance. But if I'm going to make it an instance method, on what type should that instance method belong? In this refactoring, writer will ask me which one of the incoming method parameters should I make as the target for this instance method. So really, this is like several refactorings all in one, where it's like move method and make method instance, convert method from. So this does a bunch of things all at once, but effectively it's like, hey, this is feature envy. Move this method to the type in which it's envious of, and then convert that to an instance method so it's all encapsulated on that object. Okay, so I'm going to say here, make method non-static. It's going to ask me which instance parameter I want to target for this method. Let's say the offer type object, and it's gone. Where'd it go? Up here, I can see it did date expiring. Goes offer type. Let me do this. Bang. No, I won't get rid of that. Offer type to calculate expiration date. So that method is no longer a static method on this type. It's an instance method over here. So that logic to encapsulate, or the logic to calculate the expiration date is now encapsulated on this offer type object. All right, now at this point, I'm looking at this, and this is no longer really a composed method. I have a single instance method, and now this method has been extracted out. And whenever I have this sort of mismatch between levels of kind of degrees of complexity, or just kind of the size of each of these different methods, this calls off to something else. This calls off to something else. Now this one has this other method that's just down below. So in order to understand, like, is that something I still want or not, what I'll do is undo the refactoring that I did before, which is to inline this one, inline this method to see if it's still something I want. And it's never that great to do so. So like, it sees that offer equals offer one. By the way, I've contacted JetBrains, like, why do you do this? And it's like, well, it's safer that way. I'm like, okay, whatever. So we're just going to rename this to offer. I know it was just trying to be safe for us. So now I look at it and say, okay, we have this thing calling out to external service, and then here is really now all the real domain logic. So let's actually extract all of this into its own individual method that is now just assign offer. Takes the offer type, the member, and the value. Okay. So var offer equals assign offer to the member of this type, and this is the value of the offer. Now again, we're going to perform the same kind of analysis. We look at this and we see oh, it's static. So again, we're not dealing with any other dependencies here. And everything it needs to do, and everything it needs in order to do its work is being passed in as method parameters here. So that tells me that this could be a case of feature envy, where I have this method that's only dealing with other objects that are not this object. So perhaps this logic better belongs somewhere else than on this assign offer service itself. So let's see. The way I can sort of determine this is look at each of these different parameters and say, well, like how many times, or what is the kind of main purpose of this method? I could see here that, oh, it looks like member is being dealt with 3 times. I've got offer type, which is just 2 times. And then value, that's an int, that's just some scalar number, and not possible for us to refactor and push things down into that integer. So that's not really part of the equation here. So it really just comes down to the member, the offer type, or there's this offer object that is the return value. So that's this one right here. So I could see, well, yeah, it creates this offer, but it's mainly mutating the member itself. It's kind of setting up this offer object, but in terms of like actual behaviors that are going on, that's mainly this member object itself. So the other thing I don't like here is that it looks like I have this date expiring that's just offer type calculate expiration dates. That seems like it doesn't have a very good reason to live. It just creates this local variable to immediately assign it in the very next statement. So let's inline this. I don't think there's any need to have this completely separate variable here. So let's do that. I'm going to inline this variable. There we go. And now that code comment goes away because there's no code there anymore. Actually, let's get rid of that code comment too. There's no reason for either of those comments. Okay, so let's see what we can do here. So we have the member, the offer type, and the offer, this object here. So of those 3, and based on the incoming DTO here, I am assigning an offer type to a member. And so the member is the sort of main focus here. That's the incoming overall piece of data from this incoming parameter object here. So if I were to pick and choose, I would try first the member object. Now, nothing I've been doing so far is irreversible. And so one of the things I very often do as part of my refactoring operations is try one thing, see if it looks better or feels better, if my team likes it or my pair or my Bob, whatever, likes it better. And if we don't like it, then I'll reverse it. I never feel like code that I'm working with is ever in a finished final state. And I look at using these refactoring techniques, not to arrive at a final design, but just to try out different options and different operations to see what feels best. So let's try it out. I'm going to assign offer. I'm going to do the same refactoring we had before, which is make method non-static. We get to choose, right? Do I want member? I do want offer. I don't even get to choose the offer object because, I mean, how would that even work? I haven't created the object yet, so I can't move a method to an object that does not yet exist. So of these two, member seems to be the more logical choice. Let's try that. Okay, so that private method went away, and instead of having a static assign offer method on here, now we're accessing an instance method on this member object. At this point, this service class is now pretty small, right? I've got call it to some third-party API, do the actual meat of the business logic, and then it's surrounded by database junk. So if I were to put this in a test, this class I would put in an integration test where this third-party API is extracted or is stubbed out as part of that integration test. But otherwise, I think if it was me as a tech lead or architect on a team, I would look at this and say, that's good enough. I can see everything that's going on, database, API, everything's pushed down to the domain model. This looks good enough for me. But let's go a little bit further. Let's go down into this object and see if there's anything else we want to refactor here. So one of the first things I notice as part of this is this member object has a bunch of public setters that allow anyone to do absolutely anything to this object. And so back in my service, I could do something like member dot number of active offers equals int32.min value. That probably doesn't make sense, but the public API service of my model allows it, doesn't disallow it. So although you could say like the developers would never do something like this, I have worked with many developers who would do exactly this, just for testing purposes or just to make things easier for something they're working with locally. But if this is not feasible or ever possible in the normal execution or even edge case execution of the system, why does my public API allow us to do anything with this? And in fact, this number here, which is something that when you log in is shown at the upper right-hand corner, and our business runs reports off of it, things like that. This is not something I want to allow anything to just go ahead and change at will. Instead, I would only want that value changed under very specific circumstances and scenarios that are only possible through the public API of my objects. So we can fix this by coming in here and saying, what things should be required when I first kind of create this object, and what are the things that only should be modifiable when I modify this object. So some things may be harder or more easier to understand which avenues should only be available to them to be able to be changed. So things like these first set of data, first name, last name, email, going to the business, they would tell me that you need those three things in order to be a valid member of the system, which tells me that those should probably be some kind of, let's see, generate code. This should probably be a constructor to say, you need these three things in order to construct this object. And let's make sure to check the parameters for null. So that will ensure that these three pieces of information are only possible to mutate or only are required in order for us to create this object. Now the setters are still public, so I probably could now make these private so that those are only mutable through very specific channels. In this case, let's just pretend like you can't change these once you sign up, like you never change your names or never change your email, but it may have to expose specific methods in order to make those kinds of things mutable. We would do a similar thing with the list of assigned offers. So we'd say, oh, we don't really want to allow anyone to change the list of assigned offers. We only want those to be changed under very specific scenarios. And so the way we do this is, there you go, to property with backing field. So that instead of having this being a public list that anyone can mutate, instead I'd probably make this an I read-only list of offer. And then you can only modify this collection through very specific channels. In our case, down here, you notice this turned red. So I'd say, go ahead and modify this to be assigned offers.add offer. And then finally, we said we don't want to allow anyone to modify this except through this public means. So I'm going to make this private to ensure that we cannot modify this except through this specific channel again. Now I go through the same process with these other objects to make sure that you can't create these things in an invalid state. And the way I kind of think of it is, of these invariants are, what things can I not remove before that object no longer represents that concept? Kind of like, what things do you remove from a zebra until it becomes a horse? But you can't remove the stripes. You remove the stripes from a zebra, either you're doing like some sort of CRISPR genetic junk, or it's not a zebra anymore, it now becomes a horse. So I do that for all these things as well. But if I compile it here, we'll notice that, oh, we got a compiler because there's another situation or another use case where we're mutating the number of active offers. So this is the expire offer service. So this is the flip side. We had assignments and now we have expirations. So I'm going to do the same kind of operation here of extracting methods and refactoring them to see where those methods should belong. We have initially data access junk. At the bottom, more data access junk, load, save. But in the middle is the real kind of meat of the actual business logic here. So I'm going to refactor this here into a method called expire offer. And similar to before, it's a static method with 2 parameters. I see that's this expire offer request. This bothers me. I would like to deconstruct this, deconstruct it into its constituent parts. So I'm going to do that as well. I'm going to say, looks like I'm only getting the offer ID. So let's go ahead and extract a parameter for this. Replace the 2 occurrences with offer ID. And it tells me you can safely remove this request object. Okay, so expire offer, member, offer ID, and then finally, I'm going to make this method non-static, pushing this method down onto the member object. So now I have member.expire offer as opposed to all this business logic that was stuck inside of this service class. And on my member object, we can see that this method now compiles, no more red squigglies, because I'm now inside of this object. I can access private setters. These operations now fully encapsulated into my domain model. So going back to my service classes, I've got basically, these are transaction scripts: get stuff, do stuff, save stuff. The do stuff now has been pushed down into my domain model, which also means that those methods, those objects are now unit testable. I don't have to introduce some any crazy seams or anything like that. These are now isolated objects that are just sort of purely operating on their own information, their own data. And now I can unit test those methods and those objects without having to resort to any kind of stubs or anything like that to test those methods. So in legacy systems where we have all of our existing behavior sort of scattered about, if we use these refactoring techniques, paying attention to code smells, what we wind up arriving at is a domain model. We're pushing the behavior down into these objects that now fully encapsulate the information and behavior, and we don't have to be in a greenfield application in order to do so. And to be honest, I still do this operation even with greenfield. I start with the dumbest code that could possibly work, red, make that test pass, green, and then refactor that code to where it should belong based purely on the code smells and code that I see in that method. So with that, if you want more information about this, those 2 books are great for it. The Refactoring book by Fowler and Refactoring to Patterns by Joshua Krzyzewski. And of course, the Feathers book, Working Effectively with Legacy Code. So with that, we have time for questions.
Thanks a lot, Jimmy, for for this session. If you talk about the code smells, I would just be really happy to know which are like the most important code smells that you always see over and over again. I mean, you said the feature envy. Are there other ones?
Well, in legacy systems, it's almost always long method and large type. Like we have the junk drawer. This one only had 2, right? But usually there's like member manager or member service or member helper, where it's just every time there's a new thing, dealing with that thing, just keep shoving more and more into the junk drawer. And so those are the 2 big ones I typically see. Past that, though, we're often looking at coupling to say these 2 classes are really dealing with each other. So how do we tease them apart and isolate those different things together? But for this kind of refactoring exercise, those are the big ones.
Mm. And what are like I mean, not everybody has probably jet brains. So what are the essential refactorings you need to actually do what you're doing?
Yes. So yes, I do recognize that not everyone has access to JetBrains products, though. If you don't, just beg your manager to get like sharp tools for you. But a lot of IDEs these days do have free plugins to make this kind of thing possible. So I'm in Microsoft land. Like Microsoft tooling does have some refactoring support, but I always do look for not only refactoring capabilities, but also defactoring. So unwinding things as well. I have to go there and back over and over again.
So basically the extracting, but then also the inlining needs to.
Yes, because I view code as clay and I want to be able to mold it however I like.
Yeah, nice. So let's let's go to the questions. For example, we were doing DDD, domain-driven refactoring. So do we know what is the aggregate root here?
That's a great question. So in this case, just through these sort of refactoring exercises, we may not, quote, know what our aggregate root is. We kind of have a hint there, right? Because we're encapsulating behaviors into these different objects. So it looks like member is a good candidate for our, quote, aggregate root, because it's the thing that's now encapsulating that sort of behaviors. I will say with existing systems, you do kind of know what those roots are, because you look at the main operations and use cases of the system, and you have an understanding of what are the main things that those use cases are concerned about. And that's a good indication of what your main aggregate roots in your system should be. But it's not necessarily something you can just completely arrive at. You know your entities, because those are the things with IDs, but you won't necessarily just, quote, arrive at what your roots are.
Yeah. Okay, another one also about those entities. How do you deal when there is entities with annotations? Do you still move the methods in it or remove the setters?
The annotation, so is that similar to, like, is that the Java term for annotations?
So the thing, yeah, probably.
Okay. Yes. So I do move all of that over. So everything everything that's defined with that method, it all comes with it as well. But that's why I pay attention to sort of the entire signature of that method. That includes annotations. That includes the visibility, static versus instance, and all the parameters. Like all those different things are clues to me about where this method might belong. But again, we can always try something, and we can always do a git revert. Like that's a perfectly reasonable operation for us to do.
So that's probably also where these comments come in. Wait a second, like run tests.
Yes, I swear I really should add tests for this thing. But yes, if I'm doing like true sort of in an actual project, I would be adding tests as I go as well. I'd be doing the feather style, introducing a seam, writing a test, and an integration test as I go. I was just lazy here. I was just focusing on the model. But yes, absolutely, we would be writing and running tests as we go.
Yeah. So how often do you actually run it while refactoring? Like after each refactoring step, or take some time, or any process?
Effectively, like as soon as you can compile, that's when I tend to run the test. I don't try to, just like you don't want long running branches, you don't want long running refactorings that suddenly you have 100 failing tests and you have to figure out what one change was the thing that addresses these. I know some folks use continuous testing tools, things like as soon as you save, it runs tests. In legacy code bases, that can just be beyond irritating. So it becomes sort of a checkpoint. As soon as the code compiles, okay, let's go ahead and try to run the tests. And then make a judgment call based on the failures, like, oh, we're just not ready yet, but we should try to get ready very soon.
Yeah. So a question also from Maximiliano. I don't know if you understand it. So would you do Kent-Beck's TCR with DDR? So TCR is the test commit revert.
Yep.
DDR is dance dance revolution, I think.
Maybe Maximiliano can briefly.
It's a new way of sort of TDD, where you write a test and you commit, and if the test fails, then you revert the code, so you start again.
Oh, okay. I mean, I like anything that works in very small, incrementable, verifiable steps. What I'm trying to avoid here is just a long period of time where I don't have verification. So yeah, I'm intrigued. I should have gone to his talk earlier, I guess. No, but for me, it's like, how do I take very small, incremental, verifiable steps? Because there becomes sort of a exponential growth of difficulty of fixing things the further you are away from like passing tests.
Mm-hmm. Mm-hmm. Maybe what else do we have? I think that's basically it. So the DDR is by the way, domain driven refactoring.
Oh, okay. Yeah, that's an interesting thing. Like I test commit revert if it doesn't work. I don't see why not. Sounds interesting.
Let's try it. Okay, thanks a lot again for the talk. I hope we have all learned a little bit more how to refactor our code effectively into a more domain model style. And now it's actually also announcing the next. I'm still having something here that I cannot show. Oh yeah, the next talk. It's the last talk of this conference. Is by Sonja Nathansson, and maybe interesting for a lot of people. So you think you might be an architect, and if you want to find out if you are one or not, then join our next session. This has been Tech Excellence Conference so far. You can find all the recordings on YouTube. They're already out there. So if you have missed something or want to re-watch something, then just go to YouTube and you can see it there. Also, thanks to our sponsors. If you want to learn more about these topics, then you can also check out their stuff, of course, and well, join us on Meetup and all the social media. So thanks a lot and see you in the next session. Bye.
Thank you, Jimmy. Thank you all. Bye-bye.
See you.